Okay, so according to AMBA, so we have APB protocol, advanced peripheral bus, and then AXI protocol. So AXI means advanced extensible interface. So these are the topics we will discuss. Introduction to introduction to AXI, what is AXI, okay, and then key features of AXI protocol family and users. After that, AXI architecture, and then channels, what are the channels are available in AXI protocol, and how we are doing the communication between the protocol by using handshaking, and then what are the transactions we will deal with the AXI protocol, and signals, what are the signals are available in AXI protocol, okay, all these things. Okay, so these are signals, and then types of transactions like burst calculations, and then we are doing some write transaction and read transaction, data transfer details, outstanding ordering, memory attributes, some atomic access and locked access things. Okay, error handlings, how we are doing the error handlings, and then protocol rules and violations, practical considerations, and interfacing with AXI, how AXI is interfacing with other protocols, and rules and verification for real-time implementation, and then real-time examples after the summary. So this is the content related to AXI protocol. So first we will discuss about what is AMBA and why it is used. So tell me, AMBA is a advanced microcontroller bus architecture. It's an open standard protocol. Okay, it will design that open standard protocols like AXI, APB, and AHB, all these things. Okay, so why we are going for AMBA protocols means it is high performance. Okay, it is giving that high performance, high bandwidth. All these features are it supports that. Okay, so that is the reason we are going with AMBA protocols. See, this is the Advanced Microcontroller Bus Architecture. It's an open standard on-chip interconnect specifications developed by ARM. On-chip interconnects, I told you that. On-chip means, so we have a SoC level components. So SoC is uh, communicating with some internal blocks like memory and CPU, GPU, all these things. See, say CPU, DMA, GPU, all these things are internal components of your software. I want to communicate between these components. I need on-chip protocols. Okay, so on-chip protocols and off-chip protocols, different protocols are there. So we will talk about that on-chip protocols. So related to AMBA family. So in that, this is the AMBA protocol. So here AMBA protocol is an open standard protocol. It will design by ARM. So ARM is why we are creating the ARM is it's an open standard and royalty free, and then used for millions of or billions of ARM based SoCs. Okay, so SoC means system on chip, and then defines the communication between master, slaves, and other subsystem components. Master means CPU is the master, and then other peripherals, whatever the peripherals we are talking about, all are slaves. So that means master initiates the communication, slave will respond according to that. Because master wants to controlling the data, so whatever the data is requesting and whatever the data is transferring, the master will do that, and slave will accordingly give the data as well as gives the response. That is the master and slave communication. So why we go for AMBA? I told you that. So efficient IP reuse. Efficient.
Yeah, but I have one question. Like, AMBA is a family of open standard protocols. Like, what did you mention? Like, open standard protocols means what?
APB, AXI, and AHB, all these protocols are open standard protocols.
What do we mean by open standard?
Open standard means it is available, freely available, and then so we can implement our communication protocols. So we don't purchase it those protocols to communicate it. So then
Open source.
open source only.
Got it.
So that is the open standard protocol. So they will release some specifications, and then we will follow that specification protocol rules. So why we need protocol means, so we are talking each other, right? So we can freely talking each other. There is a medium. Air is the medium in between the human people. Okay, so but the machines is not like that. Machine one is one device having their own features and other device having their own features. So we need to communicate these two devices. We need a protocol. So at that time, device one don't change their features and device two is also doesn't change their features. So at that time, we need a protocol. It will set up the rules and so reusable IPs and modular and scalable features. It will provide that and it will communicate around it, no problem in that. Okay. So that is the AMBA protocols design. And here, why we use AMBA protocols? So here, efficient IP reuse. So reuse means once we have designed one design, so after 5 months or 6 months or 1 year, so same design I need to update it. So then I don't want to go for again design from the scratch. So just whatever the existing code I have, so I need to change the some features of signals and then address and data. So those features I will change it, and again I will reuse entire components and then whatever the objects we have designed earlier, okay, those components we will use. That is the IP reuse. And flexibility, it will support to connect more devices. So there is no problem in that. See, we are connecting Ethernet cable, so it is flexible. Wi-Fi it is connecting, it is flexible to other components, right? So then this AMBA will gives you flexible to other components. Then high performance it will be providing. So then it will communicate other components like anywhere. Okay, and compatibility ensures that interoperability between ARM IPs and third-party IPs and different tools. So interoperability means one device to other device we will communicate each other. So at that time we need to operate. So because some components are not obeying some features and some components are not obeying some other features like this feature, this address, this device address is 64-bit and this is a 128-bit. So we need to give some specification. So at that time, so it is compatible there. So like backward compatibility, like so we have designed APB3. So in that, some features we have added like user signals and wake up signals. So we need to support the backward design also. So that means backward compatibility we need to provide that. That means APB4 it is designed, but APB4 is supports that APB4 only does not support the APB3 means that is not interoperability. We need to give some backward compatibility also. We are updating, right? So whatever the features starting from we have, and then we are updating day by day. So that is also implemented here, and supports widely industry adaptation for extensive documents, tools, and community supports. So it is supporting purpose. And bandwidth. Bandwidth means we are communicating large distance and then small distance. So most of the components we will communicate it because we are designing large SoCs. So large system on chips. For that also we will communicate it. So large bandwidth it will provide. High performance protocol like AXI will provide high throughput also. High data throughput means so I will communicate 10 devices at a time. So it will provide the data. Okay, that is the high performance protocol and high throughput it will provide. And latency. So most of the devices we will design low latency. So high speed we needed, latency is less and power consumption is less. So that devices only we are designing in real estate. So that is the latency related. So these are the AMBA protocol families like AXI, AHB, APB, ACE and Phi protocols. Now we are introducing this type protocol also, so it is coming in future. So most of the industries are developing this type protocol and then doing some projects related to type. Okay, so coherent hub interface. It is also related to AMBA protocol. Okay, so AMBA protocol family only. AXI is an advanced extensible interface. So this is the full form of AXI. And why we go for AXI? Main usage is high speed. It will provide. It will provide high speed, and then so whatever the data we are transferring in between the CPU, GPU, and DMA, we need to transfer the data in high speed. And then APP is a low peripherals. So interfaces, whatever the peripherals we are connecting like EEPROM, sensors and displays, all are connected with low speed peripherals. So in between that, so APP, suppose you want to communicate with high performance to low performance, we need a APP. So it's like a bridge. It is using like a bridge. It is communicating. It is a speed converter. So from high speed to low speed, it will convert. So that means we will really establish the communication between the high speed performance components and low speed performance components. Okay, that is the purpose we are going for APP. So because APP is a low power, low bandwidth peripherals like UART, timers, and GPIOs, all these things we will communicate here. And AHB is the high performance bus. So bus is carrying the signals, right? So that is the high performance bus. So here shared bus we are giving. That means HP will communicate large components. So and through high speed will provide and high performance also will provide like AXI. Okay. So AXI is the interface. Here this is the bus. Interface means one component to other component we need an interface because I told you that interface is also it's like a one component having other features and different signals are there, and then other component different signals are there. I don't know how to connect that. So then interface will take care of that. So these signals will be connected to interface and these the other system device signals will be connected to this interface. It will communicate whatever the signals they have. So whenever suppose I want to communicate the address signal, whatever the address signal is there, this will be connected to interface and then other device also address signal is there and it is also connected to interface. Then in between the medium, so these two devices interface is like a medium. So then it will communicate around, not a problem. Okay. And then Pi protocol is a coherent hub interface, high performance also. So and high-end coherent interface for CPUs and GPUs and accelerators. So it is also provides high speed and high bandwidth, high performance. So devices it will communicate that. Okay, so these are the AMBA family protocols. So this is the architecture of AMBA. Like AXI is the interconnect. So here AXI or AHB we are using. In between that there is a master and slave. So master initiates the communication here, and then slave will respond for that. So suppose CPU initiates some condition, and then according to memory gives some data to that CPU. So and then DMA is asking some information that peripherals will give that through a AMBA interconnect. Okay, we are using AXI interconnect in between the master and slave. It will communicate between these two devices. Suppose CPU want to communicate it and with the other peripherals, and DMA want to communicate with memory, or some display controls are communicating with some IP blocks. Okay, so through interconnect, APP interconnect, we will communicate. Okay, so here APP bridge we are using. So in this APP bridge, we will communicate with low peripheral devices UART. So if you want to trace where we are having the data and what type of data we are transferring from one end to other end, we are tracing that. And is there any errors we will have in while transferring the data from one device to another device? This UART tracer will identify it. And then I2C is somewhat high speed compared to that UART because it supports up to 50 Mbps speed. So 50 megahertz it will support that. And I2C is a low speed peripheral devices. If you want to communicate in between it will support some intra-band microprocessor and microcontroller communication. That means whatever the outside peripherals are there, that will be communicating through processor or controller directly. That is the I2C protocol we are using. And then, so general peripheral I/O device or parallel I/O devices. So parallel I/O device we are communicating through mouse and then USB. All these things are communicating through these GPIOs. Okay. So and then how AMBA works. See,
So
I told.
in that AMBA interconnect architecture, I have like one thing regarding when we see that AXI, so that interface is AXI interface and it is using AHB bus.
Yeah.
And for to connect with the low bandwidth peripherals, we are using APB bus.
Yeah. So if you want to communicate this high speed devices to, so some other slave devices, we use AMBA protocol like AHB or AXI. Okay, and if you want to communicate these masters, these high speed devices to low speed devices, we will use APB bridge. Okay, so high speed to high speed communication, we will use AXI, and high speed to low speed peripheral devices, we will use APB. Okay.
The AX and that protocols are not used as of now.
Exactly. See how AMBA works here. Master initiates the communication. That means master is the CPU. So issues read or write request. Suppose if you want to write the data, that means CPU will initiate that I want to write some data to that external devices. So then it will do the write operation. Or I want to get the data from the some other devices. It will issues that read operation. Write means giving the data and read means getting the data. Okay?
Write means the master will
Uh,
write to the slave.
write to the slave. So that means giving some data to that slave. And then reading means whatever the data present in the slave, so that will be received by the master. Simple thing. So I'm teaching to you. So I'm giving some information. I'm controlling, and then I'm providing some information. Okay. So then, so I'm the master and you are the slave. So you will respond, and then give some data to me. So that's way. So and then slave. If I ask something, any question, so you will respond, right? So in that way. So that is the master and slave communication will happen. Understood?
Yeah. Every time they read and write it will refer to the master.
Master. So because master is the controller, slave will respond that. So slave will send, so slave will respond and then slave will give the information. Arbitration means suppose if we are doing, see here multiple masters are there and then multiple slaves are there and which master is communicating which slave. So that will decide this arbitration. Okay, arbitration it will use the grant to one master to one slave. At a time, one master only will communicate it. So that master is communicating with one slave. After completion of that information or after completion of operation only, the other master will communicating with the other slave. Okay. So address phase. Address phase means address and control signals are sent by the slave. So whenever you send some data and then it will receive that. Okay, we need some address only. While doing write operation, you need to give the address as well as data also. While doing read operation, you need to give address only. There is no need to give the data, right? So we are getting some output from that. So I want to get the data from which location. So four devices are there. So I want to get the information from the first device or last device or middle device and then third device I don't know. So this arbitration will take care of that. Once the communication is established, once the data is completed only, the communication is finished. Otherwise, it will be stay on the communication. The master, the bus will be in uh, whatever that. So busy condition. Okay. And data phase. So data is transferred between the master and slave. During the data phase, if you are doing the communication between the master and slave, then only sampling will be happening. Okay, address phase, it will give the address. So we are putting some address on that. After reaching the address, we will communicate it. Okay, so once we are giving the address, then we will move to the database. In the database, we are getting the data or we are giving the data. And then response phase. So response phase means slave sends the response. So for AXI write or read. Once I am giving the information. Are you understood or not? How I can know? So you need to give the response from your side. So then only I will understand. Okay, so you are reaching the information what I am saying, or you are not getting what I am saying. If you if I am sending the data, you are reached or not. So or any error data you have received, you need to give the response. So if you reached okay, if you are giving okay response means you are receiving the data correctly. Okay, and you are not receiving the data properly, and then you are giving negative acknowledgement. The negative acknowledgement means so you are not receiving the data properly, then again I need to send the data or reinitiate the communication. So in that way we will reinitiate communication here. And then multiple outstanding. Outstanding means so high performance protocols will gives that means multiple masters will communicate with multiple slaves. So then one master is doing with one slave, so that master is having 10 transactions. Okay, so 10 transactions we are having, one transaction is completed, then initiate the next transaction. Up to that, these transactions will be wait on the queue. Okay, so that is the outstanding transactions. Okay, once we are completing the transaction, the next transaction will be initiated. Before, in between that, other transaction will not be initiated. So up to that, whatever the transactions you have, you need to wait in the queue. Okay, so that is the outstanding transactions. Understood?
One transaction completion means till the time we get the acknowledgement from the state.
From the slave. So that means I am sending the data and you are giving the response. That's it. So one transaction is completed. So you are not giving the response means I will wait for that response. Okay, whenever the response is came, so then I will terminate the connection and then I will initiate the next transfer. So next, AMBA benefits and summaries: the high performance, modular and scalable, reusable, standardized and low power options and wide adaptation. So high performance, I told you that data will be transferred high speed and then high bandwidth it will be supports. And pipelining means, so I told you that pipelining means one transaction is not completed, the next transaction will be initiated. So that is the pipelining operation. And then modular and scalable means if you are integrating multiple IPs, that is possible. Integrating multiple IPs means so one design you have, so that in that other design also implementing. So and then all the designs we are having, see we are having four designs. So she is having one design and you are having other design, he is having other design and he is having other design. So each and every one has their own functionality and own features. Then I want to integrate this, all the designs. So I will prepare a wrapper. So whatever the signals, input output signals you have, I will instantiate here and then here it will initiate the communication. Whenever I will initiate one communication, then which are the devices corresponding it? So it will communicate particular design. Okay, particular device it will communicate. That is the integration. Okay, integration with multiple IPs. Okay, and then scale system complexity means um, complexity we will so we are going for large and medium and then small. So small shocks we will easily identify that, but large system on chips we will not identify that, but it is scalable. So how many designs are there, how we will integrate it, so based on that it is scalable. Okay, and reliable and standardized. So reliable means so it will give long life. So that is the reliability. And standardized means so most of the things will go for basic standards. So not for individual person. All persons are treating as the same thing. So because it is independent of technology. So whenever we are implementing new technology, it will give us the support. That is standardized protocol we are using. And low power options are also we are giving, and then wide adaptation. So AMBA socks are we are giving to third party scientists also we are communicating, and then main artists also we are communicating. Okay, so these are the things like smartphones, tablets, and wearables, and automatives, network on devices like routers and switches, and IoT device. All places we are seeing this ARM process, AMBA protocol. So these are the key takeaways. And then, so a short answer, what is AMBA means? AMBA is the backbone of software. So system on chip backbone is the AMBA, and it is enabling efficient, reliable, and high performance communicating between on chip protocols. Okay, these are all on protocols. Understood? So what is the main thing we are going for here? It is so open standard, efficient communication is there, and flexible design, high performance will provide, low power options, and widely adopted. So this is all about introduction to ARM. Okay. So how AMBA evolved here? So in 1996, ASB Advanced System Bus is introduced. So this high system, so first high performance system bus is connecting that high speed peripherals. Okay, bus is carrying the information. So that is ASB is introduced. After that, going for AHB, some interface it is introduced, and then after that ATB, and then AHB light, after that AXI interface we are connecting, interconnect and interface we are introduced, and then coherence. So coherency extension, after that type protocols. So these are all AMBA protocols. Versions are there. AMBA 1, 2, 3, 4, and 5. So now we are in APB 5 and AXI 5 we are introducing. Okay. So what is protocol? See, ASB is that high-speed system bus for memory and peripherals. Whatever the memory we are using, and then outside peripherals like keyboard, mouse, and then the device we are using. For that, we are using ASB. Okay, advanced system bus. And APB, low peripheral devices and simple devices we need to communicate each other. So to CPUs and all other high performance buses. At that time, APB are using. So I already explained all these things. Okay. These are the performance demands and multiple core, coherency and scalability, efficiency, design flexibility. All are the previous slide also we have the AMBA key takeaways. Okay, these are the benefits. So what are the benefits? High performance, high bandwidth, and then high bandwidth, and then high throughput we are providing through AMBA, and then suppose everything from that small microcontroller units to large microcontroller units and CPUs, GPUs, it will support that. And ensures that backward compatibility and smooth migration between the versions. So I told you that. So if you are designing this AHB, and then AHB is also supports ASB. Okay, and if you are going that ATP, advanced trace bus, it will also support that HB and ASB. After that, AXI is also supports that, so that is backward compatibility. It will give you. Okay.
Could you once again repeat what was that high throughput?
High throughput means I need to communicate with large complex devices. So at that time, so one device is, see, in this AXI, each and every channel having independent channels. Write is having independent channel, read is having independent channel. So I want to do communication with this slave. So while doing the write operation, someone is asking reading data. So at that time also I am giving data efficiently without any delay. So that means large devices are also communicating at the time. So I will give the data. So if you are on call, then you want to send some information through WhatsApp. So on your call, you are giving your keeping your phone on speaker, and then you are transferring the data. And then if you are on a call and you want to send some money to some other person, you are doing that. So that means multiple transactions it will do at a time. Okay, that is the throughput. That throughput means we are giving the inputs. Okay, any doubt? Yes. So combine evolved the basic system peripherals and then peripheral buses to comprehensive interconnect ecosystems and supporting high performance, low power, coherency and scalability for modern soft designs.
Doubt I have, like when we said we give inputs on multiple channels. So channel are we considering it as a bus?
Channel is a communication between the two devices. So in that we will transfer the information.
So there will be multiple buses, is it like in the previous architecture diagram where you
Yeah.
had shown like master connecting to the slaves?
Yeah.
So different, like one master connecting to different slaves would be like high throughput,
Yeah.
or multiple masters connecting to multiple slaves, because only one master will be taken into consideration, right?
So
But the bus will only be one.
one master only communicating with one slave, and the other, see, multiple masters are there and multiple slaves are there, each and every one having their own channels. Okay, so then one master is communicating to other slave, so this master never communicating with the other slave because here communicating is happening, and then next master is communicating with the other slave. So the second slave is initiating the communication with third master, or fourth slave is communicating the initiate the communication for first master. So our first master is communicating between the third slave. So in that way it will communicate it. So that means
Here, like what will be the throughput when we say that it has high throughput? One master communicating with one slave, like how do we consider
so
the
throughput means it will gives the more data. So not only single data. So AXI supports some burst transactions. So burst transaction means it will give only one address. It will give only one address, single address. That means start address it will give, and then multiple data it can send. Okay, multiple data means one transfer. Suppose one byte of data you are transferring. Again, the next byte of data it is transferring in the same channel. So and does not initiate any other transaction. So same transaction only it will send multiple data. Once it is connection established, this tool only automatically calculating the next address. So because it is a burst based transaction, so what is burst and then I will explain in the further classes. So because burst means single address we are giving and it will support multiple data. Okay, it will transfer multiple data. That is the throughput. So we are giving multiple data with a single connection only. So and it will not stop the first address you have given the next address and I don't have the next address. So when I will get the next data, so it will won't allow that. So and then it will communicate. And there is no problem in between that. So multiple data will be transmitted without any connection loss. In a single transaction. So this is the SOC architecture. So real-time architecture. See, these are the peripherals like USB and then Gigi, SD card, SDIO, so GPI, scan, and all peripherals are communicating here. And then one processor. So central interconnect. So this is the central interconnect which are connecting to, see, one is connecting to IPs and the other one is the see. So this is the green line indicates that AXI 32-bit or 62-bit high performance data paths. And then here blue color lines are AHD 32-bit a high performance buses are connecting, and yellow color lines is the low bandwidth peripherals like APB, and then this black line is control and interrupt and some other custom signals we are connecting, and then indicates that dotted line indicates the second processor core, so that means dual core option we are providing. See, this is entire SOC. So in this entire SOC, application process unit APU is connecting, and then some programmable logic devices, PLDs are connecting, and PLDs are connecting, and memory interconnecting. So all the devices are connecting. Some memory input output devices are there, and then every device will communicate with central process, central interconnect AMBA. So here, low speed peripherals are connecting and high speed peripherals are connecting, and then application process are connecting. All the devices are communicating without any disturbance. the others. Okay, so this is the entire soft design tools. Okay, whatever the soft we have, that is the motherboard connection. So what we are having, all the components we are seeing here. Okay, so cache controllers, that is memory, L1, L2 levels, and DDRs will communicate, and double data rates will communicate it, and processors will communicate it, memory management units will communicate it. Okay, each and every device, it is communicating through own interfaces. If you want to communicate low speed peripherals, go for APP. If you want to communicate with high speed and then some buses you need, AAP we are using. And if you want to communicate with high speed peripheral devices and high speed components, you go for AXI. Okay, so this is all about soft. So just see this diagram, and then if we are going this, how communication is happening. Say master will communicate that CPU, DMA, and programming logic. So all these are masters, and then central interconnects that arbitrates and routes that. Okay, who is requesting route? Okay, it will communicate it, and then address and controls. Which target, which slave we want to communicate it. Okay, target slave we want to identify it. This is how communication happens. And then once connection is happens or transaction is happens, you need to give the response or acknowledgement. And then interrupt controllers. That means any external data you want to communicate it, there is an interrupt. And then why AMBA is used in this process. I told you that standardized, efficient, scalable, reusable, and future proof purpose we are using this software. Okay, AMBA connections we are going for it. And benefits of Zinc and see, this is FPGA connection, Zinc board and PIN boards we are using. That means before going to that IC, so IC fabrication they are implementing on FPGA. Whatever the operation you are expecting, it is performing on FPGA means they will go for ICs. So examples of interface like CPU or DMA, so DDR to AXA interface. That means double data rate is having high speed data. So for that AXI high performance bus we are connecting. High performance interface is connecting. AXI is the advanced extensible interface. And CPU to peripherals. CPU to peripherals via APB we are connecting. Like UART, I2C, GPIOs. And CPU to high speed IPs. So we are using AHB or AXI. Okay, and then programming logic devices to some other performance high performance ports. Okay, so PL to PS, so then we are using AXI. PL to PSI accelerators, so we are using some accelerated protocols. Okay, accelerated coherency ports, ACPs. And debug or trace, we are using some oversight components.
What is PS? PS1?
PS means here processor system and then peripheral logic device, some full form is there. So, processing system, PS. And then PL is full logic. Okay, so processor system to programming logic, we want to communicate it, we will go for some ACPs. Okay, here ACP is there. So accelerated coherency ports. Okay.
When we say debug trace via port side components,
Uh, Debug or trace means if you have any problem in that, so some errors you have identified that.
what is port side in that? Port side
Core side components means all are core side components only. So core centralized whatever that programming logic is a core. Okay, programming logic is a core. So core means main part. So CPU is a core. Okay, so it will communicate it. So if you have any problem in that, you need to debug it. So debug it and then fix the error and establish the communication proper way. Okay, so this is introduction to AXI protocol. AXI, I told you that advanced extensible interface. Why we go for AXI protocol means it gives that high performance, high frequency. So and Then it is also developed by ARM. Okay, ARM is it is a family of AMBA, advanced microcontroller bus architecture. Okay, mainly it is designed for high efficient communication between master and slave, because AXI having independent channels, all these channels we will see here, and then supports high bandwidth, low latency, and deep pipelining. Okay, high performance, high bandwidth means we can communicate large distance also, and also it gives that high bandwidth means it will communicate more components also. That is the high bandwidth. So if there is a less bandwidth means I want to communicate this person only. I don't have any bandwidth to communicate remaining three people. So this AXI protocol don't say that. So it will communicate more components because it having high bandwidth. Okay, and then um, it, uh, so it is designed for low latency. That means low speed. That means high speed it will give and delay will be less. Okay, within seconds only we will get the data, and then there is no delay here, and then it will provide high speed. High speed data will be communicating here. Okay, and anything else here? Uh, so deep pipelining or pipelining means pipelining means what it will do there means just why it is done. Okay. So pipelining means actually if you are doing one transaction here, so this is one transfer, and if this transfer is not completed, another transfer is initiated. Okay, so that means suppose you are sending address 1 in the first phase. Okay, so this is the first transfer. In the second transfer, what we are sending means the data 1, that means address 1 we are already keeping in the we already kept in the first transfer. Okay, according to that second transfer, in that data 1 I need to place it, but along with we are initiating the next transfer also, address 2 also I am transferring. Okay, so that is called as pipelining. Deep pipelining means we are completing one transfer is not completed, the second transfer is initiated. But APB protocol, every transfer at least 2 cycles it will take that. Okay, at that time, so whatever the data we are having, same pipelining only. So that means more deeper. That means it is fetching the data and executing and decoding. So same way, suppose there is a pipelining process with a 4-stage pipelining and 6-stage pipelining.
Pipeline it will, that does not wait for execution.
Does not require to
One
do.
cycle only, more instructions can be
Yeah.
Multiple instances.
Yeah. Suppose if you are doing one clock cycle, you are initiating. Suppose APP protocol, you are having two phases. So one phase setup phase. That means you are selecting which slave you want to communicate it. In one phase, you are selecting slave, and other phase you are transferring the data. Okay, so that's why at least 2 cycles it is needed to communicate between the APP protocol. Now here AXI is independent channels are there. Then pipelining is also supports means, so one data is transferring and again the next data is transferring in the back way. So in one phase you are getting some address, and the second phase you are giving the address as well as data. That means you are reducing the number of clock cycles. Suppose I want to communicate 10 transactions, so in ABB it will take 20 clock cycles. But AXI, 10 transactions it will be completed in less than 10 cycles. Because in one clock cycle, one data is transferring, and the next clock cycle, data as well as address also transferring. then two transactions, uh, two things you are doing in one cycle only. Then the next cycle will be reduced, right?
Yeah.
So one cycle is reduced. Same way, the next cycle is also reduced. So based on that, the 10 transactions it will take less than 10 cycles. So that is called pipeline. That means it will improve that speed of operation. Okay. So next, AXI key facts. What are the key facts here? Just I will go for see, and then you suppose that I told you where we are now. Here,
Yes,
key facts, right? These are explained. So used for memory map and high-speed peripheral communication. So already we have explained. So in SOC, we have CPU, DMA, and then memory management units, all these things. So it will communicate between the high-speed performance devices to other devices. So AXI will communicate it. Okay. So serial peripheral communication is also provided here, and then optimize it for modern soft designs. Whatever the see, everywhere we are using the AXI protocol. Whatever the latest design we have, so we want to communicate with high performance devices, we will use the AXI protocol. So that is optimized it. Okay. AXI key facts. What is that key fact? Developed by ARM, and it's a part of AMBA 3, AMBA 4, and AMBA 5. AXI 3 supports, AXI 4 supports, AXI 5 is also latest version. So what it means, here we are having burst transactions. I am saying that address length is there and size is there, and then what type of burst it is showing that. Okay, so based on that, the length of the channel will be increasing. In AXI3, AX length will be 4. Okay, in AXI4, it will be 16. Okay, so in that way, it will be increasing. Okay, so length is the 4 bit length we are using in AXI3, and AXI4, the length of that 8 bit we are using. That means length is 4 bit means 2 power 4. That means up to 16 bits of transfer it will support that. And then 8 means 2 power 8. 2 power 8 means 256. So here 16 bits, and here AXI4 256 bits will support. That means the length is improved. Same way, the performance will be improved from version to version. That is AXI3, AXI4, and AXI5. So that's why we will also support that AXI3 and AXI4 also. That's provide transfer compatibility. Then data transfer. So I told you that burst based transfer means the thing it issues that start address. Based on the start address, it will uh, communicate the next transfer also without stopping the data. So it will initiate the next transfer because it will automatically incrementing the address. First address, start address, it will issue that. Next address, it will calculate it based on the types of first transfers. So why AXI? I told you the high performance, separate read and write channels allows that simultaneous transactions. So one is communicating with one device, other one also will communicate it. So one is doing write operation, other one is doing read operation. So that is parallel transaction. It will support that. So that's why say we are doing one. Suppose we are doing one activity means that gives less more time it will consume. So I'm doing one operation with, and parallelly I'm doing another task, and then parallelly another task means, so all the tasks are completed at single time. Okay, one clock period only it will complete all the transactions. That is the parallel transfer. Okay, I told you the serial transfer means one bit is sending to other device, the next bit will be loaded here, and this bit will be transferred to next device, and then this bit will be transferred to this device. So four bits will communicating bit means four clocks are required. But parallel transfer means at a time four bits will be loaded into the four devices, and then at a single clock only we will get the output at the time. That is the parallel transfer. So that is the see here simultaneous transactions it will be supposed. That means parallel transactions it will be supposed. And low latency that means high speed we are providing and then low latency we are having. So pipeline architecture and multiple outstanding transactions and reduce the wait states. So in transaction means so one device is communicating with other device and other device is communicating with other device. So outstanding transaction means suppose we are having 10 transactions, one transaction is completed, then next transfer will be communicating. But these transactions are also splitting to some other masters. That means I'm having more load. Okay, I'm doing one transaction with 10 seconds. But you need to wait, remaining transactions will be wait for 10 seconds to complete the all transactions, right? So one transaction is completed, then it will take like 10 seconds. But remaining masters are idle phase. Then it will distribute them. So here 10 transactions are there, 2, 3, 4. In that way, who is completing fast, based on that, it will complete it. Because we are having faster masters and someone is having slower slaves and and then faster slaves are also having faster master is communicating with the slower slave means it will take some time and then faster master is communicating with the faster slave means it is completing more time, so less time. Okay, so that's why we are having AXI supports that outstanding out of order transactions. Out of order transaction means so we are having multiple masters and multiple slave. Faster master is communicating with slower slave means that response will be coming later. And then faster master is communicating with faster slave means that response will be coming first. So first I have transmitted the first transaction, why it is getting last means I don't know. So because it is communicating with the slower slave maybe. So that's why we are getting out of order transaction. Then how you know which transfer is related to which transaction means based on the ID, you will say that. Okay. Say high bandwidth, that means each transfer and multiple data which will be improved for data throughput. Okay. So burst transfer will support that, right? So burst transfers means single address it will be sending and then multiple data we are a single address we are initiating and multiple data are transferring. Okay, that is the burst based transactions. Okay, say this here we are
In this each action, it will be taking acknowledgements also from the stage.
acknowledgement also. Based on the acknowledgement only it will initiate the next transaction. Then we don't know is that receiving data properly or not. So then every transfer it will take that it will give that acknowledgement.
So burst transfer means only the data will be shared or once because once we get the acknowledgement then one transaction is completed, right? But when we talk about burst transfers, is it like multiple transactions or only one transaction but multiple data in that one transaction?
One transaction, multiple data are transferred.
Okay. So acknowledgement will also be one.
One only. And then flexibility we have, right? Scalability supports that various data bits like 32 bit, 64 bit, 128 based on that 1024 bits up to it will support that. Okay, and then high bandwidth, so burst transfers and multiple data bits improves the data throughputs because multiple bits means 8 bit, 16 bit, 32 bit. Based on that, it will improve the data throughput. So, and then burst transfers, it will support multiple transactions. Flexibility, so available queues, quality of service will improve it. And then IDs, based on the ID, we will know which transfer is completing first and which transfer is completing next. So protection, so it will give some secured access. So encoding will be there. So if you got any error means this will identify that protection will be identified. And catchy attributes. Attributes means these are the properties. So who will store the data. So temporarily it will store the cache memory and then it will receive the data. Reliability. So handshaking is happened between the master and slave through valid and ready signal. Every device there is a handshake signals ready and valid. Ready signal will be sent by the slave and valid signal should be sent by the master. Valid data you are sending, slave will ready to receive the data. Okay, so these are AX interconnect, which device are communicating this means CPU, DMA, GPU, and other masters want to communicate with memory, peripheral register, and other slaves. So this is the interconnect. These are the performance devices, and these are the low performance device or high performance device. Based on that, it will communicate it. Okay, it will communicate both the device. Okay, AXI supports that point-to-point bus, and that connects one more bus masters to one or more bus slaves. Okay, so this device will communicate this device. So point-to-point communication means one device to other device. So but masters will communicate to multiple slaves. So this master is communicating with the peripherals, or this master is communicating with memory, and this master is communicating with other slaves. It will be possible to communicate. Okay, multiple masters access at multiple slaves, and high-speed data transfers with bus contentions and integration of various system components in the standardized way. So integration will be possible, high-speed data transfer is possible, and multiple masters is communicating with multiple slaves through AXA protocol. Okay, so
Crossbar,
which one?
crossbar, any extent interconnect, crossbar slash interconnect.
Crossbar interconnect means I told you. So point to point communication, this is also communicating, and then from CPU to other device also communicating, and DMA to peripheral device also communicating. So that crossbar switch. That one device to this way. So we will communicate each other. Cross communication. So that means I want to communicate with one device. So for master one is communicating with slave one. Same master is want to communicate with slave two. So it will communicate it. So it's a protocol layer and protocol layer, interface layer and physical layer. So based on these layers, it will communicate it. So application layer is nothing but a software. Whatever the software we are using, in that some applications, some Zomato, Swiggy, all these things are applications. So it will communicate the user design or software. And then it's a protocol layer means who are transferring the data. So it initiate the data, read, write happens. All these things will be taken by the AXI protocol layer. And AXI interface layers means based on the channels. Okay, read write channel. So based on the channels, it will give us signals. And physical layer means so who are receiving the data because we are communicating wireless communication, but devices are communicating through wire. So that physical layer will communicate it. So physical layer will taking care of that which device is communicating with which takes a protocol family, I think. So, so AXA includes that multiple interface for different families like AX4, AX4 Lite, AX4 Stream, AX5. Okay. So these are the different protocols related to AXI. So different families. Okay, AXI4, AXI4 Lite, AXI4 Stream, and AXI5. So AXI4 is the high performance memory mapped interface. Like AXI3 also high performance memory mapped interface. But compared to that, the channel length is improved. Okay, so typically memory high speed peripherals are connecting here. What is the use of this AXI4 means? So it will communicate with memory as well as high speed peripherals. And then low complexity. So who is that? AXI4 Lite, who are having low complexity and single beat interface. So beat means number of bytes, how many bytes we are transferring. That is a beat. How many transfers is happening. That is beat. Okay. So in one transaction, 10 data are transferring means that is one beat. Okay, so beat is defines that how many data we are transferring in one transaction. And then so control and status registers purpose we are using AXI4 line. That means control and status registers means who are sending the data that is received properly or not. I need to get the status. What is the status? At the end of the day, you need to give the status where we are stands. So that will take care of this AXI4 line. And AXI4 stream means It will uh, it will receive multiple data and combined in a one packet and transferring that. Multiple what n number of data we are getting, but it is transferring it as a one packet. That is streaming. That means high throughput streaming interface like video, audio, data streaming. All these things are used by AXI core line. And extension of AXI core, some additional features like data integrity, quality of services, and then some low power signals will be implemented in AXI 5, and atomic operations like atomic operations means locked access and then exclusive locked access it will be provided. These are the key characteristics. 5 independent channels: read address channel, read data channel, and then read response channel. Sorry, read data and then address. Address, write data. During that write operation, response also there. And then read address, read data. Read response channel is not there, but read response signal is there. Why? They will ask you why read response is not there. Reading means from slave to master, right? So then slave master will not give the response. Slave only will respond that. And the next read transfer it will use that response also. So that means if you are giving the next transfer means so you are going the next transfer means the first transfer is happened properly. So based on that, the read data channel only along with that read response will be going to the master. So 5 independent channels, valid and handshaking signals, valid and ready signals are there for handshaking. Handshaking is properly maintained. Based on that only we are transferring the data. And burst transactions it will support. Burst transfers with configurable length and size. So based on the length and size, so it will support that number of bits. So that will be supported by the burst transfers. And supports multiple outstanding transactions using ID tagging. Out of order completion also I told you that. And then by lane control with right stroke signal. Right stroke signal it will define that which bytes are valid data in your transaction. That will decide this byte stroke signal. If you are sending 10 bytes of data, in that 5 bytes only valid data we are having. So that's right stroke will decide that which byte lane having valid data. And then provides quality of service protection and cache attributes. Supports both memory mapped and streaming data. So AXI is a streaming data is also there. So video controlling means it will collect all the data and then gives us one video. So that is a video streaming purpose we are using. Memory maps also we are having. See, better performance like pipelining and burst transfer is there. Mm, and then low latency overlapping of transactions is there, and then pipeline will support. So that's why low power, low latency is there, and high speed operation will be support. Highly scalable. So whatever the large device we are having, it will be scalable. That means measurable and robust and reliable. Handshake mechanism ensures that data reliability. So without any loss, it will be sending the data. And then widespread adaptation like CPU, GPU, SoCs, and then FPGAs at 6 and more devices we are using the XL protocol. Clear up to now? So just take some 5 minutes break.